In this video, we will see how Chris has not understood any of the things that we talked about in previous videos, but his own citation gives us the material to disprove his claims and so much more, so stay tuned. Hello everybody, and welcome to a sign of life, I suppose, which at the same time happens to come in the form of a video. Hi everyone, I missed you. Life happened and a lot of stress at university and deadlines about proposals and my possibly future, maybe hopefully PhD assignment, and things got in the way. And I had a lot of stuff to do, but I would very much like to come back now, even though content is slim, if you ask me. Nevertheless, my favorite YouTuber has uploaded another video, Krpytonite Physics, and this time though I'm a little sad because it's essentially more of the stuff we've already talked about. But we shall have a look at it no less, because I think by now it's our duty to do so, or my duty at least. I mean, it is your duty to watch, but yeah, let's go. The sound isn't really that horrible. I've just accelerated 1.25 because the videos are rather slow paced, which is fine. No, it's not a bad or something. It's just I would like to get through with it,
Look up at Mars tonight, shining like a brilliant orange star in the darkness. At its closest approach to Earth, it appears at magnitude negative 2.94, one of the brightest objects in our night sky. But how much light is actually reaching
anything that has negative magnitude would be pretty bright in the night sky. That's correct, yeah.
our eyes? The answer might surprise you. Just 0.00004 lux. To put that in perspective,
It's
that's
not
roughly
surprising,
25,000 times dimmer than a candle viewed from 1 meter away. Let's quickly have a look at how we get this low value for Mars. We can use Mars's stated apparent magnitude, how bright it is.
Now, and this is one of the things that will be inconsistent in this video. At one point, Chris doesn't seem to have, and this is no offense. This is just an observation, because how would he have those skills? He has somewhat poor skills in things like typesetting in a scientific context. Because if you're going to do this on a PDF and not in like comments or something, you could express this way more nicely, right?
Using the formula at the top, we get 0.00000398 lux for Mars illuminance on Earth and your eyes.
That
You
is
can
roughly
check
correct.
this yourself.
Yes.
Go on any AI and ask, calculate the lux arriving on Earth from Mars at apparent
So,
magnitude.
and this is the second theme that will be through this video. I have in the past accused him of using AI, which he has denied, curiously, and then like days later brought out a video where he's using AI to confirm his silly points by leading it to the wrong conclusion. So he's obviously using AI now, and I will talk about this in a little more detail in a bit.
Minus 2.94. Ask it to show the calculations and references. This is our starting point. Mars as we see it with the naked
So
eye.
I won't go through all of this. We know this point already. If you've seen any of my past videos, all of which will be shown at the end of this one. So essentially, his argument is what we're doing when we're looking at it with a telescope, with any telescope that has a significant magnification, like 50 times or 100 times, which is completely normal. We are decreasing its surface, the area, the brightness over the area. So technically, Mars becomes dimmer than it appears to the naked eye when you look at it through a telescope with sufficient magnification. And that is correct. I've talked about this in the past. That is correct.
Magic number 21.40.
And so the equal brightness than it would appear to the naked eye would be at 21.42 times the magnification, which would be very, very low for a telescope. Typical telescopes are in that range, somewhere in between here. And he gives the lux numbers here, right? And again, as we've talked about in previous videos, I have no issue with these lux numbers. They seem reasonably correct, certainly within a factor of 2 or something like that, from what I have calculated. So no issues here. Now comes the problem, and this is that he claims the lowest illuminance level at which red or orange percepts were reported. That he somehow his English is very poor. the lowest illumination at which which the color of red or orange could be seen, according to Chris, was 0.0032 lux. Now, the issue is here that he's clearly not read this paper. I have now, and I can tell you funny things about how phenomenally wrong he is with that. But we'll
If this is the minimum to perceive
keep
red
on.
orange in a
And so he now shows that this would be too little light to see the color of Mars. This is essentially his point. And then he tells us how this is wrong and stuff like that, right? And then at the end, he presents this thing, which I suppose was AI generated, because suddenly, where this document, this document was typeset very poorly, his next document is typeset a little better, but it gets a lot better with this one, because it has tables in it, and the calculation. This is clearly written with a latex compiler, right? This is what we use in academic circumstances to create papers and things like that. My paper will soon be out, I promise. And this is nicely typed. So this clearly isn't his work. This comes from AI, which I don't take particular umbrage with. It's just weird. Also, his way of listing references is really weird by just briefly showing them at the end of his video. Which, I mean, he has linked this paper in his description, which is nice. He has not linked any of these papers. Because I suppose that these were given by AI. There are no DOI links included. And now the thing about these papers, because as we know with Chris's citations, I don't trust them one bit. Because as one of my first videos has shown, he has just asked AI, or AI has made up video citations, and he didn't check them. So that this is a whole thing. So I went out of my way and checked a few of these citations. Now I got mixed results. For example, I could not find this first paper anywhere. I've looked at Nature Reviews Neuroscience, Volume 2, Issue 9. At these pages, I couldn't find it. I also used the search function, and in all of Volume 9, Issue 2, Volume 9, I couldn't find neural summation. I did, for example, however, find this one. This is more of a textbook thing. I did find this textbook, however, it was behind institutional access. And I was confused how Chris got institutional access, which I just suppose that these are the sources that AI had access to at some point, and he didn't bother once again to check all of these sources. Now, obviously, I'm not going to go through the hassle, maybe on a live stream or something, to see if I can find any of these papers. I've looked at 4 or 5, and I found 2. I couldn't find one, but I believe it exists. And I couldn't find another one, which I believe doesn't exist. I believe one of them exists because I found in one other paper, I found a reference to the authors and the year that would fit this citation. But of course, hypothetically, these authors could release multiple papers in a year. So I don't know. But I'm giving him the benefit of the doubt on that one. So with that one, by the way, I've also already left comments, because of course I do. And Chris's comment is particularly fun. He says here that I gave myself a thumbs up, which you can see here now. I didn't, because then it would be free. I didn't. These 2 are not from me, just so you know, Chris, okay? But your argument falls apart at 200 magnifications. I didn't even talk about that. I asked him why according to him, we shouldn't see an LED from more than 10 meters away in color, which is a video that my last 2 videos on the topic that completely demolished his claims. I encourage you all to watch it. It was great fun, and they received poor views, in my opinion. And I then told him that, and he says, yeah, why make a comment and not even watch the video? I watched the video. Of course I did. I'm not you. I watch videos before I leave comments, okay? But okay, Chris, now that you know that I've watched your video, I'm going to make a whole bunch of comments on it, because you literally asked me to do so. All right, people. So let's dig into it. I will try to be brief wherever possible. So, first of all, here we go again. It's more of the same. There's no new point, there's no new argument. We've talked about all of this, but hey, Chris apparently still thinks he has a valid point despite being demolished from each and every direction. From north over east to south and west, and from below and above. All right. So, but credit where it's due. Your citations are better this time. Congratulations, they have improved from being completely made up and frankly outrageously so to not all being made up, but you likely didn't read, I would dare to say, more than two of them. You definitely had a look at one of them, the one that you linked, because you didn't link the other ones, because why would you link your sources? So, the premise of this video, as has been done before, and as we've demolished before, but hey, why not? The claim is you need more than roughly 0.03 lux. He says 0.032 lux, but yeah, that's what that roughly greater than stands for. To see color, Mars only gives us roughly 4 times 10 to the negative 7 lux. So we should not see Mars in color. Thus, Mars should be closer, or astronomy should be wrong, or insert some conspiratorial point here. Now, as I've also discussed in previous videos, this one is true. I've also changed that to all of astronomy must measure wrong, because these two are kind of synonymous. But all of these are wrong, apart from Mars has roughly that amount of lux coming to us, right? So let's begin. We need more than 0.003 lux to see color. We've explained that before. We need more than 0.003 lux. And this is so important, Chris, please. Over the whole field of view in a continuously lit environment to see color, and your own references say so. This is the reference that you put the link to, the Color of Night, Surface Color Perception under Dim Illuminations. They had a table on which they placed little cards or little squares that they cut out of a standard reference color paper. And the thing was illuminated by a light from 1.6 meters above the table, and the lux were calculated from there. So, Chris, and this is important, the whole brightness over the field of view was given as 0.0032 lux. They measured this with a photometer that was half a meter away from the light source, which was some kind of Philips light bulb, at a 45-degree angle. So the standard measurement conditions, if you will. And there it recorded 0.0032 lux when you factor in its distance, right? So this is over the whole field of view. Please tell me you get the difference. The whole room was illuminated with a brightness of 0.0032 lux. I don't know how else to say that anymore, right? Tell me you understand this difference. This is the whole field of view, the whole thing, the whole test setup was illuminated by that. This does not correspond to the brightness that comes from a single source. Nowhere in the paper would they say that this is the brightness that reaches us from a single source or from a single one of these paper thingies, right? And to drive this point home, this would be the human field of vision. Roughly, this is not to scale. Roughly 200 degrees by 130 degrees. Sometimes I read 135 degrees and like 190 degrees, but just roughly. This is just about the order of magnitude, right? And here we have a square. In the paper, they say each square was between 8 and 10 degrees each side. So I'm assuming here 10 for ease of calculation. So if the whole field of view is lit with 0.0032 lux, and we have an orange square here that is 10 degrees each side, that means that my square has disappeared. Oh, no, it's back. I'm sorry, this animation shouldn't be here anymore. Which means that, and I should guide you through this, 10 times 10 degrees is 100 square degrees, and the whole field of view of an average human is around 200 by 130 degrees, so this is 26,000 degrees, roughly, square degrees, of course. The orange square, thus, has 0.4% of the area, and thus only emits back 0.4% of the initial brightness. Now, I'm not factoring in here the fact that the light, of course, is a spectrum and the orange will only reflect orange. I didn't factor this in because I'm just trying to give a rough ballpark a number here, right? For that, I would need to know the spectrum of the light bulb and the efficiency of reflection and all of this kind of stuff, so I won't be doing that. But the light that reaches us from the orange square, and now, Chris, this should be interesting, is 0.0000004 lux. This is 4 times 10 to the negative 7 lux. Now, where have we seen this number before? Chris, we've seen it before here. Your own citation. And I couldn't make this up. Why don't you read this stuff before you talk about it? It's baffling, but I'm so thankful that you don't. It's very funny. So this is, first of all, it's still 10 times 5 to 10 times 6 photons, depending on the things I've talked about previously. So we should easily see color, as I've shown in one of my previous videos. You only need 100 photons every roughly tenth of a second, a little less in some areas, to be able to determine color. So this is plenty. This is more than roughly 100 times more light than you would need to see color, Chris, from one of these squares. This is not a surprise. Literature agrees with me. See my past videos where I've cited the sources for how many photons you need in order to see light, which, by the way, was also one of your citations. They should see its color. And funnier even, now there comes the square again. I find this funny. Sorry, I will not correct this. This is funny. Light from the orange square is 4 times 10 to the negative 7 lux, which is the same as Mars, and they see it in this experiment. Chris, do you understand what you're doing here? You're using a paper that directly disproves your claim, trying to support your claim. This is so funny to me. How did you not read that? I am baffled. I'm truly baffled. Let's move on. Oh, here it is again. Imagine now, for me, if only the square was lit and nothing else, no of the surrounding field of view was lit, then the square would receive way less light than 0.0032 lux, but would still be visible. You need to understand this, Chris. There's no way that you cannot understand it. This is the perfect example. Imagine if only the square was lit. It would be less than 0.0032 lux. And you would still be able to see color, because the surrounding, if anything, the surrounding light inhibits your ability to see color. So about the claims that we shouldn't see Mars, been there, done that. I've talked about this previously, where I've calculated for every planet in the solar system how many photons would reach our eye. And by the way, this corresponds to what we can actually see with our naked eye. So my model, my way of how I think we see light, corresponds to observational evidence within the globe or the established model of the solar system. Yours doesn't. Just saying. Also, you have severe overconfidence again. So you claim at the end of your video that all star and planet measurements in regards to brightness must be just wrong. So what you're thinking is, all of astronomy measures wrong for centuries, despite of billions of whatever currency, euros in my case, in astronomy research for thousands and thousands of astronomers. And we all measure wrong and we never notice. And you figure it out specifically, with no astronomy training. I'm not saying that this is impossible, but I'm saying that this should be the very last conclusion to draw. Have you seriously considered any of my arguments? I don't think you did, because the very fact that how you replied shows that you didn't actually engage with my argument. About the new references, I said that before. I found some. None of the old ones, by the way. I find that funny. None of your old citations that you gave in the very first video on this topic, or on the video series on this topic, are in there. Are you admitting that they don't exist? Please tell me, Chris. If you comment on this video and you're not replying to this point here, this is a loss for you. Either way. Why are your old sources not in there? Some, as I mentioned before, are behind institutional access. How did you get them? Did you pay for them? I assume you just didn't get them, which is a very dishonest thing to do. And I couldn't find some others, possibly because there was no DOI link included, but also possibly because the AI has hallucinated them. And I am certain that it is compiled by AI. So, in summary, you have no new points. You didn't engage with the criticism beyond saying no, as in the past things. You still have not carried out an experiment. You did not comment on my past experiment, other than, well, I've used to you, this LED looks to be an 8,000 millicandela LED, despite me showing the actual manual from this specific LED where it says that it is about, I've forgotten the exact number, 300 microcandela or something. So you're essentially accusing me of, oh no, it should be, I said 1,000 here, it's not literally 1,000, but you claim, oh no, this is more than 100 times brighter than you claim, or like more than 20 times brighter than you claim it is, which is such a weird point to make. Why would you go around assuming how bright my LED is despite me having shown the manual? Because you were confronted with evidence that didn't suit your conclusion, so you're just trying a way to dismiss it. Extremely poor reasoning there. Chris, repeat this experiment with a known LED. I bet you won't. I bet you won't. I would bet money on that, actually. So you also clearly didn't read your references, and we've already talked about all of that. These are all of my videos that are on the topic of this specific line of reasoning. And I really enjoy making videos about this stuff because it's relatively simple physics, but you need to think about it, and it helps me understand stuff. So actually, I will have to say thank you. But the last two here are a complete demolition of your line of reasoning, which you have not given any valid reply to other than, oh no, you used an LED that was 80 times brighter than it says in the manual. This is the only reply you've come up to this far. And by the way, I've calculated, which I assume you haven't seen, that the yellow LED from the last experiment here would need to have 1,600 candela, which is more than, I think, 2,000 times brighter than it actually was in order to see color according to your claims. Your claims are off by more than a factor of 3,000 times with the experiment that I made, which is a horrible failure. Horrible, ghastly failure on your part. Yeah, I don't have to say anything more. This is the end of my presentation. To you, the dear viewer that is not Chris, I thank you so much for watching. I hope you enjoy my demolition series here. I very much do. I will try to be back with more streams and more videos, but time is currently a little tight, so I'm very sorry for that. But yeah, with that, I thank you very much for watching. If you enjoyed this video, maybe consider leaving a like. If you enjoyed it a lot, consider considering subscribing, and I will hopefully see you in the next video or stream that will not take 3 months or something for me to come back to. All right. See you. Have a good time. Bye.